done. Okay, guys, a very warm welcome to my lesson for today, where physics is what we are going to be looking at. Again, we're going to be doing a revision very quickly on my screen. Just be aware that I'm still having that flu on top of members, so you might be surprised with my voice being on and off. Just be aware that it's because of that reason. So a revision that we're going to be looking at is based on this question paper, where I would like for us to just discuss a few things related to the forces. Because what happens is the moment you get to grade 12, the only different or something new is the fact that when it comes to the forces, you no longer just have the forces, but you multiply it by the distance in order to calculate work done. So what makes something to be work? It is the product of a force and a distance. So there is no way you're going to manage with the topic where you need to do the work, energy, and power without you being able to identify or calculate the necessary forces which may be acting on an object. So there we are having question number 4, where you are at all the times advised to start on a new page. So there they are saying it is 2 blocks of mass 8 kg and 4 kg respectively, which are joined with an inelastic string of negligible mass. The string runs over a frictionless pulley. The 8 kg block is on a horizontal surface, while the 4 kg block is on an inclined plane of 40 degrees. With the horizontal being the horizontal, okay, the coefficient of kinetic friction for both the blocks is 0.2. The 4 kg block accelerates down the slope. Okay, so I think most of the information is indeed represented on that diagram, even though not all of the information is written there. But now we've got 4.1, where they say state Newton's second law of motion in weights. So for this one, for today, just comment with the answer in the comment section. So you don't unmute and state it for everyone, but you comment in the comment section. Did you guys hear me on that one?
Yes, sir.
Okay, then it's fine. I'll just be waiting. So it is Newton's second law that you need to state in weights. You just comment in the comment section, and then I'll check it. From there, we will move on to the next question. So remember, guys, in today's lesson, it doesn't necessarily need to be a long lesson. It will depend on how long it takes us to complete this question. If we complete it in 2 minutes, then it's done. But otherwise, if it takes us longer than usual, then we will be on until we have answered all the questions. So just make sure to participate so that we'll get to the cream of the question. Let me check. I'm just wondering if you guys, not yet, okay. Guys, the first question, you need to state Newton's second law of motion in words in the comment section. There's the first comment. Okay. Let me wait for some more responses on that one. Let's see.
Oh, yeah.
Sec, okay. Let me wait for the last comment and from there we will continue. 4.1 is what we are looking at. Let's see if we've got last comment. Okay, guys, anyone to comment so that we can compare and move on to the next question?
Yeah.
And those two, okay, then it's fine. We will move on to the next question, which says, this is 4.2. It says, draw a labeled free body diagram of all the forces acting on the 4 kg block. Let me quickly check something. And quickly check something. Okay, so guys, can someone just verify for me? Are you guys able to attach an image in the comment section? Because if that is the case, then I will need you to work on that free labeled body diagram to submit you attached in the comment section or in the chat box. Guys, can you just check if you are able to attach an image or a photo in the comment section? I think you should, because on my site, I'm able to. You see on my screen, when I go there, I click that plus on the chat box. It gives me an option to attach a photo or a file. So that's how you check it.
So can you show us one more time? I didn't see.
So you go to the chart somewhere on your screen, just like you attach an image. I'm not sure how it looks on your phone, but there must be something, an icon that you can click on to attach something. And this is how it appears on my site. Can you see?
Yes, sir.
Yes. Do you have that option? Mendlonke, can you check if you've got an option to attach? Guys, anyone to confirm? Guys, can you hear me?
Yes, sir.
Yes, sir.
Okay, then it's fine. So what I want you guys to do is to draw that labeled free body diagram. And then once you've drawn it, you take a photo and then you attach it in the comment section. That's where I'll find it. So this is to avoid you sending it via a WhatsApp inbox because I've got my phone on the charger. But for now, I want you to do it and then I check it there. Then I'll comment based on what you have done while you'll be seeing what I'm going to be commenting on. So 4.2 is where we are. Let's see. Wait, guys, what's happening there? Are you still working on it? Or what's happening? Atayanda Ithan Helri Lavelle say comment long, okay? Share the file in the meeting, okay? So someone has submitted, that is a win, okay? And it's fine, let's see. So loading, okay. Now I can see the 4 kg, there is a drawing. Okay, 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 okay. Then it's fine. I'll be waiting for another one. Serene was able to open and check your attachment. Guys, I'll be waiting for your attachment. So my expectation is that everyone needs to quickly work on it and then attach once you are done. So if you take longer, I will then focus on what was submitted. So you will lose an opportunity to make your own mistake and be corrected on it. For now, let me go back there and then I'll just give you a few more minutes to work on it. Okay, let me check. There is that, okay. Then it's fine. It's fine. I will then continue based on those two. Okay, so this is what happens, honorable members. Let's quickly check. So obviously we are drawing on the 4 kg. So you will definitely have a dot there. Then once you made a dot, then you will always have this one. That's why I start with it. This one going down, you must label it and say FG. And then the next one after FG, I always draw the normal force. I check if it exists. It will exist if a surface is there and it has to be perpendicular to the surface. Then you can just say N there. And then afterwards, you need to check if there is applied force. Applied force, it is not there because when we look at the diagram, it is not drawn. Also in the statement, no one mentioned anything that has to do with the applied force. But there is definitely a kinetic friction, which means there is a frictional force. How do you choose which direction will be the frictional force? You just need to know where is this system moving. Is it moving up an incline or is it moving down an incline? So if it's moving up, then the frictional force is down. If it's moving down, the frictional force is up. So that means frictional force is always opposing the direction of the movement of the object. So because in the statement they said accelerates down the slope, so that means the frictional force will therefore be up the slope. So this is where now we will have our frictional force. And lastly, you do the tension. So the tension again will definitely be in that direction. So this is how it will generally look like. I'm not sure if there are any questions, honorable members, but I did try to explain each and every force before I draw. Serene, I hope you did notice a mistake on that one. And trust me when I say you will never forget if you've done something and it was explained. Are we okay on that one?
Yes, sir.
Yes, sir.
Yes, sir.
That's fine. So now, let's move on to the next question, which says calculate the frictional force between the surface and the 4 kg. You will not be able to work out this if you do not know what is the formula for the frictional force. Maybe for now, let me not say much, then I will give you guys a chance to find what the formula is for calculating the frictional force. And then from there, do calculate that frictional force. Once you are done, you send your answer in the comment section, just like Serene and the other honorable members did, so that I can check. Remember, guys, it helps me a lot, not only myself, but everyone else, when you attempt these problems and you get them wrong. Just do what you can based on your understanding. Never care if it's wrong or correct, because if you don't do it at all, I won't be aware as to what's confusing you. But you see what Serene did there. I was able to therefore notice something, which then made me to improve on my explanation regarding how do you know in terms of which direction will which force be? How do you know what guides you? What are the tricks that one can use and all of that? So just make sure to attempt every question, then you submit, and then I'll respond based on that. I hope you guys were able to hear me on that one. So for now, I'll give you some time to work on it. Maybe let me check. Did you guys hear me on that one?
Yes, sir.
Okay, I've got a submission there. There's Serene who's got an answer. Okay. So Serene, I want to see the calculation. I actually want to see the calculation. So that means you'll need to just take a photo and then attach, just like you did with that one over there. Want to check if you've calculated it using the correct method, so that I will see if you missed some marks or not, because sometimes you lose marks not because the answer is wrong, but because you skipped important calculations or you skipped important parts. Very much important on that one. So I'll give you guys enough time to work on it and submit. Okay. Serene is good in attachment. Let's quickly check. Okay. Let's see. Not that. Okay. Then it's fine. Waiting for some more calculations. Serene, I did see your answer. I'll just wait for some more, then we'll continue. Okay, I think now is the time. I think now is the time. Let's see, Long has done something. Okay, check. Okay. Okay, let's find out. Maybe let me talk to Serene. Serene, can you hear me? Can you unmute yourself, honorable member? Serene, can you hear me? I'm not sure if Serene is able to unmute. So I cannot unmute. Okay, then it's fine. I'm mostly interested in you understanding simply because of your participation by attempting that question. But I'll explain something, Serene. So this is what happens. What we know is that the formula for calculating frictional force is equals to mu normal force name. So now this is the situation, Serene. Let's say an object is on a flat horizontal surface like that one name. So in this case, if we had to draw a labeled free body diagram, we were going to have FG. And then the normal force, we just have that going down. Remember this one, mg, it's equals to, that fg is equals to mg. So for this type, we will therefore know that, okay, the frictional force is equals to mu normal force. And in this case, because the object is not moving up or down, so that means the normal force is balanced with the frictional force. That is why normal force in this case is equals to mg. Why? Because this object is not moving up or down. So that means the normal force is equal or is balanced with the fg. Then in this case, it would mean you will say your mu multiplying by your mg. That will give you whatever mu, whatever that, but you just need to remember that force is measured in newtons. So you need to say N in the end. Now, there's another situation that you need to look at, where now the object, it is no longer on a flat horizontal surface, but it is on an incline, just like that as an example. So what you need to know is that FG will always point downwards, but normal force will go in that direction because it has to be perpendicular to the surface. So in this case, our normal force cannot balance with that one because they don't act in the opposite directions, in direct opposite directions. But that is why now we end up having the component of that FG, which we call FG perpendicular. And again, we will have this one of FG parallel. Those two components, they replace this one. So that means this force is no longer included in the calculations. This only happens when the object is on an incline. So now you can see that the normal force is now balanced with the FG perpendicular. This is where now we can see our normal force, it is balanced with FG perpendicular. Why? Because this object is not moving in that direction, and again, it's not moving in that direction. These two forces balance each other. So that means in this case, our frictional force will therefore be equals to a mu FG perpendicular. Still, it is mu normal force. But our normal force when an object is on an incline is FG perpendicular. So that means we will therefore have our mu mg. If it's perpendicular, then it is cos of an angle. That means this one of mg parallel, it is the one for mg sine of an angle. So that is why in our substitution, we will therefore, for that one, have that mu of 0,2. The mass is 4. That one doesn't change, 9.8. Then you have cos of an angle, which is 40 degrees. And it does give you that, I think it's 6,01. Your final answer, you need to say Newton. So that means we would use this formula if we had to calculate the friction on the 8 kg. But for that one on an incline, it will therefore be the one for cos of an angle. I'm not sure, does it make sense, honorable members? This is now my question to everyone. I want to check if you guys understand what I was explaining there. Serene, can you explain if you are, or let me know if you are happy with that explanation? I'm aware you are not able to unmute yourself, but everyone else, did you guys understand what I've done there? Because to be honest, in today's lesson, that's all that I wanted to explain. That is the main thing that I wanted to explain to you, because I noticed you struggle with that a lot, not understanding the formulation of frictional force. Did you guys understand?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then it's fine. Let me add.
Sir,
Yeah.
sir, if I heard you correctly, you said if the object is on an inclined surface, in the calculations of the frictional force, we do not include force by gravity.
Yes, we don't include force by gravity, but we deal with force, gravity perpendicular, and force,
Perpendicular.
gravity parallel. We deal with its components.
Okay, sir. Now I fully understand.
Yes, because we want the back and forth forces when we formulate, because you see this one is taking a completely different direction. But when we do calculations, we want, if the normal force is in that direction, we want to work with its opposite force, of which the one in that direction will be FG perpendicular. If the frictional force is in that direction, any other force must either be parallel to that force or oppose that force. That is why this one that takes that direction, we resolve it, because it's not opposing any force. Does it make sense, Liseko? Is it Liseko? I think it was Liseko.
Yes, sir, it was me.
Yes.
One
you
more
did-
question, sir.
Mhm.
How come we include force by gravity in the free body diagram, but when we're calculating, we do not include, we do the FG perpendicular? Would I be wrong if I would just include FG perpendicular in the free body diagram and not include force by gravity?
So what I know is that if you don't want to include FG, you must include both its components, being the FG parallel and the FG perpendicular. But if you include one component, is wrong. So that's why I used to say, for the purpose of a labeled free body diagram, we use this one of FG. But for the purpose of calculations, we use its components, being FG parallel and then FG perpendicular. So this one is for the calculation and this one is for a labeled free body diagram. So you will see on old past papers, they will say for a learner who did not include this one, but they included both the components and set FG parallel and set FG perpendicular, then give them a correct. But if you only show that one alone and you don't include that one, it's wrong, because the forces experienced by that object, it is both this one of the parallel, both that one, or otherwise the right way to go about it is this one of just saying that. I'm not sure if you are answered, Lisek.
Yes, sir, you answered me correctly. I understand now. Thank you.
Okay, 100%. So let me add something very much important, honorable members. So now let's say we have an object on that horizontal surface, and then again we have a force. Let's say this force is acting at an angle like that, and this is the force applied. So I want you guys to be aware that this object is going to be moving, but it's not moving in that direction of the applied force. It's moving towards the right, which means it is moving in that direction. So that is why we will therefore refer to this as our force applied. You can say horizontal. And then this one will be our force applied vertical. Obviously, that force applied is acting at a particular angle to the horizontal. It therefore means, if I had to draw a labeled free body diagram, I will therefore say I've got this one that is always there and going down. I also have this one that is the normal force. And I also have this one being force applied vertical, which is the component of that force applied. What I drew there is for the purpose of calculations, but for the purpose of a labeled free body diagram, Liseko, it is therefore best to show it like that and say, this is my force applied. But when you do calculations, you just need to remember that you have this one of Fg, you have that one of the normal force. You also have that one of force applied vertical. Why am I showing you this? It's because when it comes to the normal force, it's going to be this. Because the object is not moving up or down, that means those up and down forces balance each other. Meaning the upward forces being the normal force together with the force applied vertical, they balance with the Fg. So that means for this diagram, the normal force, it is therefore equals to Fg minus force applied vertical, which is equals to mg minus this one being the force applied vertical, it will be force applied vertical sine of an angle, which is that angle. Therefore, when you calculate your frictional force, that means the formula, which is mu normal force, it will therefore be equals to mu into mg minus force applied vertical sine of an angle. So don't just always assume that frictional force, its formula is mu normal force. No. It's not like that, or it's not fixed like that. It depends on the situation. You must know all the upward forces and all the downward forces. They must balance. After balancing, you make n the subject of the formula. Did you guys hear me on that one? That's all that I wanted to explain in today's lesson, honorable members. Everything else, not really. Did you guys hear me on that one?
Yes, sir.
Yes, sir.
Okay. Then it's fine. Glad you did hear me. So, let's now continue. With us continuing, I will just have to remove all of these. And we'll follow that. Okay, there is the next question, honorable members, where they want you to calculate the magnitude of the acceleration of the system. Maybe let me explain to you how to formulate for that one, and then you will take it further. So you just need to remember that in such questions, you will need to cut that system there so that you just focus on the 8 kg. On the 8 kg, what we know is that obviously F net equals to MA. All the forces acting on the 8 kg, what I know is that towards the right, we have tension force. I'm going to minus because this force is acting in the opposite direction. And that is the frictional force. This will therefore equals to MA. So I've got the tension. The frictional force in this case, it is your mg. No need for a cos, because in this case, it is not on an incline. Remember, this is for the 8 kg. So the aim, it is just to make the tension the subject of the formula. That means we have MA that you will plus it with mg, but remember the mu. Why mu? Because it is the frictional force. So now that we have made T the subject of the formula, why did we make T subject of the formula? It's because what we know is that after cutting, this tension is the same as that tension there. The tension is the same. It doesn't matter whether the other object has got more mass and then the other has got very little mass. And the reason for that is because even when they accelerate or when they move at the same pace. It doesn't mean the one with a smaller mass will be moving a bit faster than the other one. So the only difference is that the tensions act in opposite direction, but is the same value. The tension on the 8 kg, when you cut it, it acts in the positive direction or towards the right. It's like it's pulling that 8 kg. But when it comes to the 4 kg, it's like that one is dragging it. It's like the 8 kg is dragging it backwards. So they're actually pulling each other in a way. This one is being pulled in that direction towards the right. This one is being pulled in that direction towards the left. That is why it is positive tension and negative tension. So you will realize that when we do for the 4 kg, you will therefore notice that actually we have this force in that direction, which is the FG parallel. And then we have the tension going in that direction. We also have the frictional force going in that direction. Which is why now when you formulate, you will say it is positive FG parallel minus tension minus frictional force, which is equals to MA. So now what you're trying to do is to make T the subject of the formula. So you will take T to the right hand side, it becomes T, which will be equals to, you already have your FG parallel minusing your frictional force that you already calculated minus MA. Obviously, this one is mg sine of an angle minus the frictional force, you've already calculated it, minus the mass, which is the 4, the acceleration, which is what you are looking for. So can you see, you made T the subject of the formula. So it's like you are solving now for simultaneous equation, where this is your equation number 1, this is your equation number 2. All that you do is to equate both the equations and then you solve for your acceleration. So that means this one of MA plus mu mg, you equate it to this one of mg sine of an angle minus the frictional force, you've already calculated it, minus MA. You just need to remember as you substitute, you say on the other side is for the 8 kg, which must be equals to this one for the 4 kg. Why did you equate those equations? Is because their tensions are the same. You made tension the subject of the formula because you know tension is the same. Just always be careful of such these questions in an exam. Let me quickly check, because this is the cream of the question. That's what I wanted to explain to you in today's lesson. Any questions, honorable members? Or did you all understand what I've done there? Guys, did you all understand? Or any questions?
Understood, sir.
Understood. Serene, understood. Because sesiqedile manje. Sesiqedile manje. I'm just curious to know if all of you guys understood. Okay, if we've got no questions, then we will leave it here on the members. But by looking at that question, which says, how will the acceleration compare if the opposite, if the positions of the 8 kg block and the 4 kg block are switched? Choose from greater than, less than, or the same. Explain the answer. Obviously, if you swap, it will move a bit faster because what is it? Your FG parallel will increase. And with FG parallel increasing, that will obviously influence the acceleration. Acceleration will increase, and then that answers the question. Obviously, the tension remains the same, remember. When it comes to the tension, whether you swap or you don't swap, the other one has bigger mass or the masses are equal, the tension throughout will be the same. Tension is like the pain which is being felt by the string between those two objects. The tension may only change if you now either increase or decrease the masses, but if you swap, the tension remains the same. Then that's it, honorable members. That's it from my side for today, but trust me, you need to be able to understand this topic because before you can worry more about the work, energy, and power. If you don't understand this topic at this level, then you just won't manage. I hope you guys were able to hear and understand me on that one. So now I'm running away, honorable members, until we meet again.